Okay, here are the answers to 412, review part 2. 429 said to solve graphically. Could you solve this graphically? Explain. So to solve it graphically, I just sketched the graph real quick. Kind of was a straight line. There was a little bit of an exponential. So it crossed at 1 and 3. And the answer is no, because we don't know how to solve exponentials yet. Problem number 30 said consider those two graphs at right. Write the equation you could use. So you just take it straight from the two functions and set them equal to each other. What's the solution? So it crosses at 0 and 4. So x equals 0 or 4. And it said, then we could check it. So we would plug them back in to check, which you would just do 1/2 0 minus 2 cubed plus 1 and set it equal to 0 squared minus 6 times x, 0 minus 3 for the first one. I'm not going to check them both. You guys could write out a formal check. For part B, are there any solutions? The answer is yes. Higher up, there's a solution. C, write an equation you can use to part C. So C's equation would be 1/2 x minus 2 cubed plus 1 equals 0. So if we estimated it, it's approximately 0.75. Part D, what's the domain and the ranges for both? So f of x, the domain, and g of x. F of x domains is all reals, and it's also the same for g of x. For the range for f of x is all reals. But g of x, its y is greater than or equal to negative 7.5. Problem number 31, solve each equation using any method. So first I added 5 to both sides and got 2 groups of x plus 3 squared equals 0, divided by 2. Take the square root of both sides, so I get x plus 3 equals 0. So x equals negative 3. Part B, I subtracted 6 from both sides, got 3 groups of x minus 2 squared equals 3, divided by 3, got x minus 2 squared equals 1, square root, x minus 2 equals 1, or x minus 2 equals negative 1. Add 2. So x equals 3 or 1. For C, I'm going to add 6 to both sides. So I get 2x minus 5 equals 21, and 2x minus 5 equals negative 21. So 2x equals 26, or 13. 2x equals negative 16. X equals negative 8. D, subtract 1 from both sides. So I get 3 groups of the square root of 5x minus 2 equals 6. Divide by 3. Square both sides. So 5x minus 2 equals 4. So 5x equals 6. Divide by 5. I get x equals 6 over 5. Problem 32. I am going to solve for y. So I subtract 5x from both sides. And I get negative 3y equals negative 5x plus 12. Divide by negative 3. Y equals 5 over 3 x minus 4. F, first I'm going to multiply by r squared. So I get f times r squared equals g m sub 1 m sub 2 divided by g m sub 1. So I end up with m sub 2 equals f r squared over g m sub 1. So e, solve for m, so first we can multiply both sides by 2. I get 2e equals mv squared divided by v squared. So I get 2e over v squared equals m. For d, I subtract x minus 4 squared from both sides. So I'm going to get y minus 1 squared equals 10 minus x minus 4 squared. Take the square root of both sides. Y plus 1 equals plus or minus the square root 10 minus x minus 4 squared. Each time I do that, I change it. Add 1 to both sides, so y equals 1 plus or minus the square root of 10 minus x minus 4 squared. Problem 33, Paul states that a plus b squared is equivalent to a squared plus b squared. Joyce thinks that something's missing. Help Joyce show Paul. So I would have made a generic rectangle and put a and b here, a and b here. This is a squared, b squared, but she's missing 2b, or ab and ab. So it should have been a squared plus 2ab plus b squared. Problem 34, graph each of the following equations. Keep the graphs handy. You need them for 414 later on. So for this one, it's just an absolute value because it's x. So it's a parent function, it's just this graph right here. But for b, since it's the absolute value of y, it actually flips it and it goes this way. So how are they similar? They're both v's. They go different directions, that's how they're different. What's the domain of part A? It's all reals. What's the range? It's y is greater than or equal to 0. What's the domain of part B? X is greater than or equal to 0. And what's the range? All reals. Problem 35, find x. So we have to use sine and cosine to do this. So for the part A, we're going to do 27 over the sine of 40 is equal to x over the sine of 30 because we're using the law of sines. So we're going to cross multiply and we get x sine of 40 equals 27 sine of 30 divided by sine of 40. These cancel, so I get x equals 21. For b, we're going to do x over the sine of 114, because the first thing I did was 27 plus 39, 66, and subtract it from 180. So I got 114. So, and then that equals 81 over sine of 39. Cross multiplied, I got x sine of 39 equals 81 sine of 1. It's hard to see. Divided by the sine of 39. So then x ends up equaling 117.6.